Hi students, how are you? Hope you are all doing well and you are all safe. So today our topic is adiabatic process. So in this video we are going to learn about the adiabatic work done. So adiabatic, as its name says, it is actually derived from a Greek word adiabatic. Adiabate. So a means not, dia means through, bait means hot. So in short we can just say this process actually means where no heat exchange is occur. So in adiabatic process we can assume from the first law of thermodynamics W plus del U is equal to 0, as Q is here 0. So W is equal to minus del U. So we can explain it as we can derive work from the negative change of internal energy. So you can see this curve. This curve basically says how this adiabatic process is actually taking place. So see, this is state 1 and this is state 2. So this change is actually this adiabatic change. So you can see in state 1 the corresponding pressure is P1 and corresponding volume is V1, and in state 2 the corresponding pressure is P2, corresponding volume is V2. So in adiabatic process P V to the power gamma is equal to constant. So we can say P1 V1 to the power gamma is equal to P2 V2 to the power gamma is equal to constant. So these things we are going to apply in our work derivation. So in this equation of work we will get integration V1 to V2 P dV. Now in place of this P, we will be just substitute this P with the help of C by V to the power gamma, because from this equation we will get P is equal to C by V to the power gamma. Now as C is constant, we will be taking it outside of this integration, and then V1 to V2 V to the power minus gamma, as it actually it was 1 by V to the power gamma, so it will become V to the power minus gamma dV. So from this integration we can find out V to the power minus gamma plus 1 divided by minus gamma plus 1, and this upper limit and then lower limit. Now what we have to do, this V2 1 minus gamma minus V1 1 minus gamma 1 minus gamma, that is the remaining that will be in denominator portion. Now as this gamma will have a value that is greater than 1, generally for air we will be having gamma value as 1.4. so as we can see this value is greater than 1, so this thing will give a negative value. So that negative value can be neutralized if we take this V1 to the power 1 minus gamma in front of this V2 to the power 1 minus gamma. So simply this in place of this C, we can replace this C with the help of this P1 V1 or this P2 V2, because in this portion as it is V1 we will be multiplying it with P1 V1 to the power gamma, and in this place of V2 will be multiplying with P2 V2 to the power gamma. So as this gamma will be cancelled, because it is plus gamma and here minus gamma, both the cases it will be cancelled, so we will be getting P1 V1 minus P2 V2 divided by gamma minus 1. So as we know, this P1 V1 is equal to RT1, or this P2 V2 is equal to RT2. So we will be replacing this value in this equation and we will be getting RT1 minus RT2. So R will be taking as common, so RT1 minus T2 is divided by gamma minus 1. So this will be the work done formula for the adiabatic process. Okay, we'll be using this formula to find out some answer in case of they ask about work done in adiabatic process. Now, as I have already discussed you about the PDV work, so for each cases why I am taking in case when I am just trying to find out work done, why I am taking integration PDV. So the answer is that, see, this is dw means work done, so dw is equal to F into dx. So F is the force, dx is the displacement. Now F is force, so we know pressure is equal to F by A. Now from this equation we can find out F is equal to pressure into area. So we'll be just replacing this value here, so we'll be getting like pressure into area into dx. Now we will be just multiplying this area and this dx, will be getting the change in volume, that is dv. So by this way, in case of this work done, we will be getting this pdv value. So this is the reason why for each of these polytropic processes, let it be isothermal or adiabatic or isochoric or isobaric, we will be using this pdv equation. So that's for today. Hope you all enjoy this lecture. Thank you.